This section is 3.07 literal equations. So some sample literal equations you can see here. These are also called formulas. They are when we have multiple variables and there are very few actual numbers. Sometimes there are numbers, sometimes there are not. You can see, for example, y equals mx plus b has no numbers in it. But some others, like this top one, 4a plus 2t equals s. It's important to note that capital letters are different than lowercase letters. Here, maybe I'll make up another example here. You could have, say, 4a minus lowercase a equals b. That would be a literal equation or a formula. And in this case, the capital A and the lowercase a represent different variables. So just keep that in mind. And with no numbers or fewer numbers in an equation like these, we have to really focus on using the inverse operations in reverse order, which is reverse order of operations, which is PEMDAS. Remember, that means parentheses would go first, exponents, multiply and divide is the third step, add, subtract is the fourth and last step. That's the order of operations. When we are solving an equation, we go in the reverse order. So addition, subtraction, we do the inverse of whatever we see there first. Then it would be multiply and divide. We would do the inverse of whatever we see there next. We're not going to see any of these, but if there were exponents that we had to undo, we would do the inverse of an exponent, and then parentheses, anything inside parentheses would actually be taken care of last. So, and then remember inverse operations, those are things like adding and subtracting our inverses, multiplying and dividing our inverses. Those are the main ones that we'll be looking at. A couple familiar formulas here, hopefully, that you recognize them. But now we're dipping into two steps or multi-step literal equations. So we're solving for x, but we're going to have to do it in a couple steps. So see, x is right here. There's m that's being multiplied and b that's being added. So this is where the reverse order of operations comes more in play. Before, all the other problems just had one step. These will start to have multi-steps. So this is the order of operations, parentheses, exponents, multiply, divide, add, subtract. But reverse is you just read this going the opposite direction. I mentioned this earlier in the video lesson. So we take care of addition and subtraction first, right? That's our first thing to take care of. So I see that we have addition. So we'll undo that. So we're still doing inverse operations. So the inverse of adding b is subtracting b. And of course, you got to do it to both sides. Okay, so now we would have y minus b on the left equals m times x on the right. I guess I forgot to cancel out the b's, but they do cancel because they're inverses. So we did the addition subtraction, moving backwards. So now we're looking at multiply divide. And that's what's going on here. This is multiplication of x, or multiplication of m. The m is what we want to cancel because we're solving for x. So we're going to divide by m. And we got to divide this whole side by m. And then the m's undo each other. They cancel. And you're left with y minus b over m equals x. And since I'm running out of space, I'm just going to leave it that way rather than flipping it around. Okay. Another one that we want to solve for x on. Here's our x. We have, this is a times x, and then we have by added over. Again, take care of distance subtraction first, so we can subtract. Now we're not just going to subtract b or just subtract y, but we can subtract that as a group or as a single unit. Also got to do it to the other side. They will make 0 here on the left. We still have a times x, ax, but now on the right it's c minus by. And kind of like that last one, this is multiplication, so we will undo it by dividing, but this time we just have a different number. So this actually looks pretty close to that last one here. Pretty similar. Those a's cancel, and we're just left with x equals c minus by all divided by a. So it's like one big fraction. Okay. So solving for x, again, we have, let me write out the order of operations. I think it's kind of nice to see it and then draw my little arrow. Hey, we're going backwards. So we're solving for x. It's x divided by ml, m times l, minus 6 equals t. So maybe think about which thing we'll undo first. And so we should be looking, is there any addition subtraction that we can undo? And there is. There's a minus 6, so that's what we should take care of first, adding 6 to both sides. And they cancel here on the left side. We still have x over ml, and we usually, whenever we have l, we usually use cursive, so it doesn't look like a 1. Anyway, and then we just have t plus 6. And now we have division, but we also have multiplication. But remember, this is a single number. So I would focus more on the division, which is the next thing. And the way we undo division is multiplication. So on this side, we'll multiply by ml. And I don't have enough space over there, so I'll put it in parentheses, ml, I'm multiplying by. And I also have to do it on the right side, but it's all of t plus 6 that I'm multiplying ml by. So we definitely have canceling on the left side. I feel like that's the easier side maybe to understand because we know they're inverses. Now, this is a little different. We have two variables, but it's being multiplied inside a group that's being added. And you might not recognize it possibly, but maybe you would. This is another distributive thing, but instead of distributing a single number, we can distribute both ml. That's fine. We can do that and multiply it throughout. So we could write this as x equals ml times t, we could say is ml t. When you're multiplying, you just write the variables next to each other. Plus 6 times ml is 6 ml. So the actual calculations are not, well, actually, we're not really doing any calculations, but you just need to know what to do with that, and it's distribute. And now we got x all by itself on one side. We're all good to go. Okay, this next one, we have a fraction. So again, we did one kind of like this before. We have the x right there. We have b being multiplied and a 1/3 being multiplied. And I would try to take care of these separately because of the fraction. There's a special way. We did an example earlier. Think about how we might do that. How might we get rid of that 1/3? And hopefully you're thinking about reciprocals, right? So it's 3 over 1 that we're multiplying by, and do that to the other side. Now, remember that 3 over 1 is just 3. That'll be nice to know for the right side when we're multiplying by k. But anyway, 3 over 1 times 1 over 3, those are going to cancel. We're still going to have b. We haven't done anything to that yet, b and x. And here's where I know that 3 over 1 is just multiplying by 3. And k times 3, we could just write as 3k. I like to have the number first. You'll typically see that. But you could write k3 instead if you'd like. And one more step, though, to undo that b that's being multiplied, we'll divide by b on both sides. Leaving us with x equals 3k over b, or divided by b. Examples, here's where you can get a little trickier, and this one could confuse you, and I think that's rightly so, because when it says solve for x and you see, hey, there's 2 x's here, that's a little more complicated. Now, we're actually going to do a move that's technically called factoring. Another way that I sometimes describe it is reverse distributing. So distributing, remember, is when you have a number, so kind of like over here on the right, you can distribute this 4 to each thing, and then each of those things will have 4 being multiplied to it. So notice here, you could imagine that maybe x was distributed to each term here, because we have x being multiplied on each of these. So if we were doing distributing backwards and pulled the x out, then neither of those terms would have x on the inside. So it would look like this. Now you might wonder, okay, well, how did I know to do that? Well, the reason why we do it is because that move takes 2 x's in this upper original equation and makes it into just 1x. Now we just have 1x, which is much easier to solve for. And it's being multiplied by this big group. But remember, that big group we can just think of as one entity, and that's being multiplied. The inverse of multiplying is dividing. So we can divide that whole thing by 2L plus P, that whole group. Also divide the right side by 2L plus P. It's a plus sign. Okay, therefore the 2L plus P's cancel. And then we're left with x equals A on top, capital A, over 2L plus P. Okay, and now this last one. We're solving for x, but it's kind of stuck there inside the parentheses. So if you remember, order of operations is that PEMDAS mnemonic word, and we want to do it reverse, so that P, the parentheses, is actually what we'll do last. So we're not going to mess with anything inside the parentheses yet, which is the minus C. So we'll take care of this 4 that's on the outside that's being multiplied. Do that first. And the way you undo multiplication is division. So divide by 4. Do that also to the other side. So the 4's cancel, they undo. And then you're left with x minus c. Now, since there's nothing else, we don't need those parentheses anymore. It's just x minus c. Oh. Equals t over 4. And now there's just one more move to do, and that will be to add c, the inverse of subtracting c. And the c's cancel. And the way you write this will be x equals, and we have the t divided by 4 first, and then we can add c after all that. Okay, don't be afraid to come back to this video as you're working through your assignment, so you can check examples. That's why I've gone over so many different examples, so you can be prepared for the ones you might come across. Good luck.